Imagine for a moment that everything you know, everything you perceive, every star, every galaxy, every whisper of existence is contained within something far grander, far more mysterious than we can possibly imagine. What if our entire universe, with its endless space and countless wonders, is merely a tiny bubble nestled inside a black hole? This isn't just a wild idea from science fiction. It's a deep question that challenges how we understand reality, a question that some of the smartest scientists are now asking. Is our universe, in fact, inside a black hole? This idea, as strange as it sounds, opens up a world of possibilities and makes us think about the very nature of our existence. Get ready to explore the deepest parts of cosmic thinking, where the limits of what we know are pushed and the familiar becomes wonderfully, even a little frighteningly, alien. Before we dive deeper into the amazing idea that our universe might live inside a black hole, let's first understand what black holes really are. For many years, these giant cosmic objects have fascinated scientists and everyone else because they are some of the most extreme and mysterious things in space. At its simplest, a black hole is a place in space where gravity is so incredibly strong that nothing, not even light, the fastest thing in the universe, can escape. This huge pull of gravity happens because a massive amount of matter is squeezed into a tiny, tiny space. Imagine the weight of a star, or even millions of stars, packed into a ball just a few miles wide. This squeezing twists and bends the fabric of space and time around it in an extreme way. The point of no return, where escape is impossible, is called the event horizon. If you cross this invisible line, you are forever pulled towards the black hole center. From far away, anything falling into a black hole seems to slow down and disappear as it gets close to the event horizon, never quite crossing it. But for anyone unlucky enough to fall in, the journey continues, though to an unknown fate. In the traditional view of gravity, at the very center of a black hole is a singularity, a point of infinite density and no size, where the rules of physics as we know them completely break down. It's a concept that truly stretches our imagination and our scientific models. Black holes come in different sizes. There are stellar black holes, which are usually a few times heavier than our sun and form when huge stars collapse. Then there are supermassive black holes, which can be millions or even billions of times the sun's mass. These enormous objects are thought to be at the centers of most galaxies, including our own Milky Way. Now, let's explore the truly mind-bending idea, the theory of black hole cosmology. This bold idea suggests that our entire universe, the one we can see and study, is actually the inside of a black hole. While it sounds like something from a science fiction movie, this concept comes from serious scientific research. This idea was first suggested independently by physicist Raj Kumar Pathria and mathematician Irving John Good in the early 1970s. More recently, this fascinating idea has been explored and refined by physicists like Nikodem Poplawski. The main point of their work is that our universe isn't just like a black hole. It is a black hole, existing as one of possibly many inside a larger, parent universe, an idea that naturally leads to the concept of a multiverse. But how can this be? If black holes lead to singularities, and our universe clearly isn't a singularity, what's going on? This is where the Einstein-Rosen theory comes in. It offers a key difference from Einstein's original theory of gravity. In Einstein's theory, when a huge star collapses, it always forms a singularity, a point of infinite density where space and time become infinitely curved. However, the Einstein-Rosen theory introduces a new feature, torsion. Torsion, in this case, is a property of space and time linked to the tiny spinning motion of matter. When matter collapses to extremely high densities, as it would inside a black hole, the Einstein-Rosen theory predicts that this spinning interaction between tiny particles creates a powerful repulsive force. This force acts like a cosmic spring, preventing a true singularity from forming. Instead, the collapsing matter reaches an incredibly high but limited density and then bounces back, creating what's called an Einstein-Rosen bridge, or a wormhole. This wormhole then expands, forming a new, separate universe on the other side. A universe just like ours. This revolutionary idea suggests that the Big Bang, the moment our universe began, wasn't a single event from nothing, but rather a non-singular big bounce. It was the rebound from matter collapsing inside a black hole in a universe that existed before ours. Or, some versions suggest the Big Bang was the emergence from a supermassive white hole, which is like a black hole running backward in time, born from a black hole in that parent universe. This theory neatly solves the singularity problem in Einstein's original theory and offers a compelling way to understand how our universe began, not as a standalone event, but as part of a bigger, connected cosmic cycle. It paints a picture of a universe constantly creating new universes, each possibly nested within the other, like an endless set of Russian dolls. While the black hole cosmology theory offers a clever answer to some of the most puzzling questions in physics, what real evidence or interesting coincidences support it? The idea is still very much a theory, but certain observations and mathematical connections have made its supporters curious. One of the most striking coincidences is the relationship between the Hubble radius of our observable universe and its calculated Schwarzschild radius. The Hubble radius marks the boundary beyond which objects are moving away from us faster than light due to the universe's expansion. The Schwarzschild radius, as we discussed, is the size of a black hole's event horizon. Amazingly, the Hubble radius of our universe is found to be almost exactly the same as its Schwarzschild radius, calculated based on the universe's estimated mass. For some scientists, this almost perfect match is too precise to be just a coincidence, suggesting a deeper link. However, it's important to know that many mainstream scientists see this as an interesting but ultimately accidental, numerical match without direct physical meaning. More recently, a fascinating piece of potential evidence came from a study published in March 2025, which looked at data from over 200 early galaxies. The study found an unexpected pattern. About 2/3 of these ancient galaxies were observed to be spinning clockwise. In a truly random setup, you'd expect roughly half to spin clockwise and half counterclockwise. This big difference from randomness is puzzling. One strong explanation within the black hole cosmology idea is that if our universe is indeed inside a larger, spinning black hole, then this cosmic rotation could influence the direction of spin for the galaxies within it. All known black holes are observed to spin, and this rotational effect could spread down to the structures forming inside. Of course, good science requires looking at other explanations. This observed oddity could also be caused by other, still unknown, cosmic events that make the universe slowly rotate as a whole. Or, like with any new and complex set of data, there might be small errors or issues in how the data was collected or analyzed that need more investigation. Nevertheless, the galaxy spin anomaly provides an interesting new piece of information that, while not definite proof, certainly adds another layer of mystery to the black hole universe idea. If the black hole cosmology theory were proven true, the consequences would be nothing short of revolutionary, completely changing how we see reality and our place in the universe. Imagine the huge shift in perspective. We are not just living in a vast, expanding universe, but possibly residents of a cosmic birthplace, born from the collapse of a star in another, larger universe. This realization is both humbling and incredibly powerful. First, it would redefine what existence means. The universe, instead of being a single, isolated thing, becomes part of a complex, connected network of cosmic creation. This could strongly support the idea of a multiverse, not as many parallel worlds, but as a layered structure where universes are nested within universes, each potentially creating new ones. This repeating pattern of cosmic evolution, where collapse leads to new life, offers a compelling alternative to the traditional straight-line view of the universe. Second, it would force us to rethink our understanding of time and space. Inside a black hole, space and time are bent to an extreme degree. If our universe is truly inside one, could certain cosmic events, like the accelerating expansion of our universe, be effects of the larger black hole's movements? The theory of shockwave cosmology, for example, suggests that the Big Bang itself was an explosion inside a black hole, and the acceleration we see might be a leftover effect of that initial shockwave. This challenges the need for ideas like dark energy, offering a more unified explanation for why the universe is expanding faster. Philosophically, This theory is deeply meaningful. It speaks to the idea of cosmic recycling, where nothing truly ends but instead changes and gives rise to new beginnings. It suggests a universe that is not only huge but also endlessly creative, constantly making new realities. This way of thinking can be incredibly empowering, reminding us that even with immense cosmic forces, there is a natural energy and potential for renewal. However, it's important to recognize the challenges and criticisms this theory faces. Black hole cosmology is still a fringe theory, meaning it's not widely accepted by most scientists. Many physicists argue that while it's mathematically interesting, there isn't enough observational evidence to support it over the standard model of cosmology. Critics point out that the universe, as we observe it, seems to be expanding evenly in all directions, which isn't what you'd expect if we were inside a spinning black hole. The galaxy spin anomaly, while interesting, is just one observation and needs much more data and independent checking before it can be considered strong proof. Also, the Einstein-Rosen theory, while it solves the singularity problem, is itself a change to Einstein's original theory and isn't yet widely accepted or fully tested. The scientific community demands strong proof, and while the theory offers elegant solutions, the real-world evidence is still very new. Despite these criticisms, just thinking about such a radical idea pushes the limits of human thought. It encourages us to question what we assume, to look beyond the obvious, and to embrace the mysterious nature of the cosmos. It reminds us that our journey of discovery is far from over, and the universe still holds secrets that could change everything we thought we knew. So, we return to our first profound question: is our universe inside a black hole? We've explored the mind-bending ideas of black hole cosmology, looked at the interesting role of the Einstein-Rosen theory, and examined the subtle, yet compelling, coincidences and oddities that hint at such a possibility. From the curious match of the Hubble and Schwarzschild radii to the puzzling clockwise spin of ancient galaxies, these whispers from space invite us to rethink where we are in the cosmos. While the theory remains on the edges of mainstream science, it stands as a powerful testament to humanity's desire to learn. It's a reminder that our understanding of the universe is always changing, built on discoveries and challenged by new observations. The beauty of science isn't in having all the answers, but in constantly searching for them, in daring to ask the boldest questions, and in pushing the limits of what we believe is possible. Whether our universe is indeed a cosmic baby within a larger black hole, or if this theory eventually gives way to new ideas, one truth remains: the cosmos is infinitely more mysterious and amazing than we can ever fully grasp. Every new discovery, every new theory, peels back another layer of the cosmic onion, revealing deeper complexities and more incredible wonders. This journey into the idea of a black hole universe is more than just a scientific exploration. It's a philosophical awakening. It encourages us to look at the night sky with fresh wonder, to think about our own place within this grand fabric of space and time, and to embrace the powerful change that knowledge brings. The universe isn't just out there. In a very real sense, we are part of its ongoing, mysterious creation. Thank you for joining us on this incredible journey through deep cosmic thought. If this exploration has sparked your curiosity and opened your mind, please consider liking this video, sharing it with other cosmic adventurers, and subscribing to our channel for more journeys into the unknown. Your support helps us continue our quest to uncover the universe's deepest secrets. Until next time, keep looking up and keep questioning everything.